Hey folks, welcome back to Clear My Paper. We are continuing with our possibly the final session on solving type 1 and type 2 problems on the matrices and determinants, which includes matrix addition, subtraction, scalar multiplication, and matrix multiplication. And this is specifically for the examination problems that appear for first year diploma basic mathematics for Maharashtra State Board. The paper code is 22103. All right, let's jump in. So a quick recap, right? I think I did not mention this in the previous sessions. We know that the matrices, the overall weightage is roughly 20 marks, right? Like I said. But out of that, broadly, I divided into 9 sets of problems. I think this covers everything. But regardless of that, type 1 and type 2, which is addition, subtraction, scalar multiplication, and matrix multiplication put together, they roughly come for 8 marks. So just remember the weightage of the importance of this so that you can plan your strategy on where to put your time accordingly. So type 1 and type 2 put together roughly will have 8 marks in the examination, and the remaining will be distributed. Remaining 16 marks out of the 20 will be distributed somewhere here. Okay. All right, let's keep going. So in the last 2 or 3 videos, we have covered for the most of the problems on this type 1 and type 2. Like we have covered this, we have covered this, we have covered this, okay? And most of the problems, like I said, were belonging to type 2, which is pure play matrix multiplication of two matrices, right? Like this, okay? In this video, the last 2 problems, which incidentally happened to be a part of summer 2018, and there's nothing in 2017 related to type 1 and type 2. So roughly the 8 marks for these 2 problems in summer 2018 are predominantly related to the matrix. At least this one specifically is a type 1 problem, type 1, where we're talking about addition, subtraction, and some sort of scalar multiplication. And this one, the next one, is a combination, type 1 plus type 2. So we'll see both of them. I'll possibly try to cover this in the same video. And wherever I think it's very easy or you can understand the drift, I'll kind of pace it up. Okay, so let's jump in. Okay, let's take this problem first, the 2a for 4 marks on this one over here, the type 1, and then we'll move to type 2, or we'll move to the next one. Okay, all right. For ease of reference, I've written the problem here. Okay, summer 2018, question number 2a for 4 marks. There are 2 matrices that are given, A and B, which are 2 by 2 matrices. This is again 2 by 2. Okay. And the question is, find x such that 2x plus 3a minus 4b is equal to I. So again, I'm reading the question, find x such that 2x plus 3a minus 4b is equal to I. So before I start the problem, like I always say, first understand the question 2 or 3 times, get the hints, compose yourself mentally what you're going to do, have a plan, and then start the problem. So if I'm reading this problem in the examination hall, I'm going to take a quick deep breath and think in my head, close my eyes and think in my head, what are the ingredients I have to cook this particular problem, right? Now, I know that this looks like a type 1 problem where it has a combination of addition, subtraction, and scalar multiplication. I know that. It has got the first point. The second point is at the right, it has got something to do with identity matrix or unit matrix. Okay, that's given. And I know in my head that any matrix where all the diagonal elements are 1 and all the non-diagonal are 0, that's kind of a unit or identity matrix. I know that. I know both the matrices given are 2 by 2, and hence I've taken a 2 by 2 identity matrix. Okay, and also I know, if you remember in the first 2 opening videos, I've said matrices can be looked at from 3 different lenses. One, you're solving a simple numerical problem or a normal number algebra. 2, you can apply matrix algebra, and 3, you can apply the geometric lens or the mathematical or the matrix transformation concept, right? So in this case, if you see, this is a pretty straight equation where it's kind of, you can apply the first lens where you're seeing this problem as a simple algebraic problem. It's not a linear set of equations because there's only one equation, but it's a very straightforward problem where we have one equation and one unknown over here, right? If it was not a matrix, it would have been a one equation, one unknown problem, and you could have found that, right? And the most important thing, the thing in the red, that's the most important thing, right? like I said, always avoid this kind of problems if possible, or keep it for the later in the examination, during the examination, because you can solve this, okay, but it will be very hard for you to verify the answer, and even if it's easy or there is a way to verify the answer, you will have to put some extra time and efforts, and these are kind of prone to calculation mistakes, so always be careful with that. And I'll show you how to verify the answer of this one. In this case, it's still possible. In some of the cases, it might not be possible, or it might take a very different route to do the verification. Okay, let's jump in now. Okay, so I'm taking the left hand side here, the 2x plus 3a minus 4b. I'm writing it down here. Okay, I'm given the equation, and since I'm going to solve it like a simple one equation, one unknown kind of problem, I'm bringing the unknowns on one side and bringing all the knowns on the other side. After that, this 2x, okay, after that I'm going to substitute each of the matrices. For example, since all of the given matrices A and B are 2 by 2, I'm going to use the identity matrix as 2 by 2, because if you have to add and subtract, the matrices need to be equal, which means the rows and columns should be same across the board for all of these matrices. Okay, so I'm taking a 2 by 2 identity matrix where this and this are 1 and other are 0, minus 3, and I have the given matrix in this bracket, plus 4, and then I have given this matrix that is given in the sum. And just as a quick check, when you just have a number outside the matrix that is multiplying the matrix, that will be treated as a scalar. That means this number is going to scale up this matrix 3 times. This number 4 is going to scale up this matrix by 4 times, and these are 2 by 2 matrices. That's also I told you, right? So I'm continuing on the left hand side. I'm just keeping it 2x. I have not simplified the substitution x yet. I need to still find the values of x, but I'm keeping it 2x on the left hand side. And on the right hand side, I'm slowly starting to simplify this. I'm keeping the unit matrix as it is, taking the scalar, multiplying it. Do not get confused with this minus sign, or do not do a mistake. I'm keeping this minus as it is for now and just taking this number, the whole number, and multiplying it, and you get this. Similarly, I'm taking this scalar and multiplying this, I get this. Then I continue, 2x still remains the same. On the right hand side, I just do simple mathematical operations, addition and subtraction, because the matrices are equal, because all of them now have 2 rows and 2 columns, right? So I'm just doing simple, I'm taking the first 2 matrices. If you want, in the interest of time, you can take all of them together also, if that helps you. But for simplicity, I'm just keeping it the first 2 matrices. I'm going to subtract the matrix in the middle from the leftmost. So there's like 1 minus 9. The respective elements within the matrices will get subtracted. Again, be careful. There is a negative sign here and there is a negative sign. So always be careful with that. And this, for the timing, I'm keeping it as it is. I'm not getting into the equation yet. Then I get this 2 matrices. From this, I get this, and from this kind of stays back. This kind of stays back. And then again, I apply a simple algebraic addition operation on the 2x, and finally I get 2x is equal to this, right? This is where we are. So I get 2x is equal to this. And if it was a simple, not a matrix, if it was a simple equation, then you would have taken the 2 on the other side by dividing both the sides by 2, and you would have got this equation, right? So I'm just taking that. So if you see here, x is equal to half. So I divide by both the sides, the 2 goes other side, I'm keeping it half. And I'm keeping this matrix as it is. This is one way of writing the answer, where you're writing it in the scalar form, where your scalar number is half, and then you write the whole matrix. Or if you want to go further downstream, you can multiply the scalar and show the final answer, where you take this half inside and multiply and show this kind of this way, where this comes as fractional. So either way is fine, you can show the answer. So now we have this answer. Now how do I know my answer is correct or not? How do I make sure that I got my 4 marks? I spent significant amount of time in writing this. So since it's a simple mathematical addition and subtraction, I can take this very equation, 2x plus 3a over here, right? I can take this very equation and put back the values in to make sure my right hand side becomes I of this matrix, unit matrix or identity matrix. And that we can do it, right? Because I have the value of 2x, I have the value of 3a, and I have the value of 4b all are computed. If you see, this is my value of 2x here. If you see, this 2x is here, and 3a is here, I've computed already, and 4b also is here, I've already computed, right? 4b. So I can take the respective matrices, and over here I'm doing a quick check. I'm taking 2x plus 3a minus 4b. All these are already computed above. I don't have to break my head. Just be smart enough that you don't try to again recalculate this. You already have the 2x here, so straight away take it from here and not from the final answer. Okay, and I'm putting back the values. I'm doing a simple addition and subtraction of the matrices, and my final answer is indeed identity matrix by 2 order, and hence it matches the right hand side, and hence my answer is verified. So this step is kind of a little detour, but it's worth it to ensure that you want to do your 4 marks, because there is an easy way to do that. In certain cases, which you'll see in the next problem, you may not have an easy way to do that. Okay, so that's a wrap up on this question. Hopefully this was easy to understand and you guys can practice it yourself or shoot me if you have any questions. Okay, let's keep moving. Now the next column that I told was the last column in summer 2018, the same paper 4A and for 4 marks, where it asked me to find x and y. If there is an equation that is given, I need to find x and y. So again, this is a simple problem. If I read it peacefully, take a deep breath, and if I read peacefully, what do I see in the problem? Okay, I see, okay, there is a scalar, there is a matrix, so I know there is going to be a scalar multiplication on this and this. Then this arrow shows me that there are going to be 2 matrix multiplication. There's going to be a matrix on the left side and there's going to be a matrix on the right side. So in this case it's type 1, but when it comes to this solving 2 matrices, it becomes type 2 kind of. So it's a combination of type 1 plus type 2. Like I said, there's an addition subtraction element, there's a scalar multiplication, and there is a multiplication of 2 matrices. So type 1 and type 2 kind of a fusion problem. And like I said, if you calculate this right, there is no easy way to verify whether the x and y answer that you're going to get is going to be right. So you need to be very careful while calculating and not do any silly mistakes, or better avoid these problems if you have a choice in the question set to replace it with something else where you can verify the answer easily or something of that sort, because this is going to take time and there is no easy way to verify your answer. So be careful on this one. Okay, all right, let's jump into the problem. So I've written the problem as it is, and like I said, there's a combination of type 1 and type 2. The first 2 operations are basic. Type 1 subtracting 2 matrices, because both the matrices are equal in terms of rows and columns. So I'm subtracting element to element, this to this, this to this, and this to this. Okay, I'm subtracting and then I'm bringing it here. So I have now 2 matrices, and I know this is kind of turning into a type 2 where I'm multiplying 2 matrices. I know that, so I need to check if the multiplication is possible. So the first matrix is a 2 by 3 where we have got 2 rows and 3 columns, right? Second one has got 3 rows, okay, and 1 column. So I'm writing it. Take the inner 2 numbers, which is nothing but the number of columns on the left and the number of columns on the number of rows on the right. Both are matching, so multiplication is possible. And what would be the final order of the matrix? Since we know in the exam they have given that the final value is x and y, we know that there are going to be only 2 rows and 1 column in the output. But even if you go by this logic where you take the outer numbers, this and this, which is the number of rows on the left matrix and number of columns on the right matrix, it shows me the order is 2 by 1, which matches to this, and hence we are on a good track. Now we do a simple multiplication like I taught you. Take this 1 row, right, and apply on this, and then take this second row and apply on the same column like this over here, and do the additions properly. Be careful about the negative signs wherever it comes, and then you get an answer where you finally get the final matrix, which is column matrix, which has got only 1 column, 2 and 4, and then output is x and y. So by equality of matrix, since both the rows and columns are same, I can straight away map the elements where x is equal to 2 and y is equal to 4, and that's the final answer. But it will be very hard for you to put this answer back and verify in some format, and that's the reason I told that be careful with these columns or avoid it all together if possible. Okay, I think that's the wrap up, guys, on this video. I think this concludes all the examination problems for type 1 and type 2 on this set of problems that should secure 8 marks in the examination. And the next videos will again start with some theory and some interesting facts about what is a transpose, understanding it intuitively, and then we'll talk about transpose as a type 3 problem and solve some of these problems. And that way we slowly will cover the entire syllabus on matrices. Hopefully this format helps you, it helps you understand the concepts. If not, let me know if you need any changes. I'll be more than happy to accommodate your request. Alright guys, stay tuned, wait for my next session on transpose. Bye bye.